Hello, everyone. Today, we have an interesting panel about sharing psychophysiological information in architectural design. And before we get to the topic, I would like to introduce the speakers of this panel. So I'm honored to have here with us Professor Stephen Law from UCL, University College London, who is an expert on uh, the application of data science and AI for urban design, also called urban analytics. We also have here with us Professor Michal Gath-Morad from the University of Cambridge, who is an expert of the relationship between cognition, neuroscience, and the built environment, that is studying how people respond to buildings. And we also have with us Professor Mitsue Nagamine from the Institute of Science, Tokyo, who is an expert of psychophysiological measurement, which means measuring phenomena such as stress and so on, which can help us also manage these things. And myself, my name is Yuval Kahlon. I'm from the Institute of Science Tokyo as well, and I focus on developing interactive systems to support designers and also to enhance design education. So let's jump into the topic. I think that everyone recognizes these icons. We see them every day. These are the famous sharing icons, right? We share things all the time with others and with ourselves sometimes. And we are inside this sharing culture where we constantly distribute information instantly to other people. And of course, this is not only negative, this is also positive because others can know what is going on with us at real time. And on the other hand, some aspects, such as the fact that the private and public boundaries are blurred, also should be thought of in parallel. But in design, in architectural design, this culture of sharing information in real time is reflected in the development of tools for real-time collaboration. So this is just one tool, which is not specifically developed for designers, but designers use it quite a bit. This is Miro. And by using Miro, architects can share information with each other in real time, which is very helpful. And this kind of tool or technology has a lot of implications for how we design. For example, it's hard to define who made the contribution to the project when everyone is working on the same thing simultaneously. And so far, most of these tools that have been developed for architectural design or for design in general focus on sharing information about the project itself, the building, the spaces, the artifact we are making. But nowadays, there is a shift which is ongoing. And this shift is related to technologies which are becoming more and more accessible. For example, take an Apple Watch or any other type of watch that can measure your heart rate. And then imagine a scenario where a designer can share her heart rate with the design team. So in this case, can have many implications for the way we are designing. For example, we can detect the fact that someone is stressed and then we can respond accordingly. So what I want to argue here is that we are experiencing a transition between sharing only information about the building or the design into sharing information about the designer and about the people who actually make the building. And these things are exacerbated by all kinds of interesting technologies. For example, eye tracking technology. Here you can see someone walking down a street in Tokyo wearing a mobile eye tracker, and the red circle shows where are they focusing. And of course, there are also other technologies that are relevant here. For example, using EEG, we can read brain signals from people and then get information regarding their mental state. For example, you can see that this area of the brain is more active than that one, and that may imply that the person is more interested or stressed and so on. And these are kinds of psychophysiological information. That is information that relates the bodily processes, how our body processes things and responds, and also mental processes. That is how we feel about something. As I mentioned, when you feel stressed, there are also other processes such as changes in brain state and so on. And these processes can tell us that someone is stressed, which is hard to detect. It's hard to directly observe mental processes. So learning about these relationships is very important. And going back to the eye tracking example from before, there was a very interesting experiment by Brennan and colleagues where they let two people work in parallel on a search task. So person A and person B are different rooms, and they're trying to find something together. And then when we share the gaze information, when person B knows where person A is looking, they can solve the task faster than without this, which means that sharing gaze information, sharing the psychophysiological information is helpful for collaboration. And design, of course, is all about collaboration. So to better contextualize this, I want to give an example from a project. This is an ongoing project called Tomorrow Studio. And at the first stage of this project, we tried to see whether we can take the traditional scenario of trying to teach architectural design without any special technology and then augment it by using advanced technologies such as augmented reality, eye tracking, and so on. And we improved upon the study that I showed earlier by Brennan et al. And in their case, they let people share the gaze on a flat monitor. But in this case, we let people share their gaze information in an immersive environment. So what you see here is the display of two different people, an instructor and a student. And when someone sees a red circle, that means the other person is looking there. So you can imagine how useful this kind of information can be for an instructor because they can suddenly realize when the student doesn't understand what they say and they can adapt the way they teach on the fly. So of course, this technology and other ways of sharing psychophysiological information is very useful, but at the same time, it's not perfect. And I really appreciate this comment by one of the instructors in our experiment. And he said that sharing the gaze with students was useful, but sometimes he didn't want to do that. So, and the reason I appreciate this comment is because it shows a very interesting contradiction between the goal of education, which is to teach better, and the goal of the individual, which is to feel in a certain way. So, in this specific case, the instructor said that sharing gaze information sometimes can feel intrusive. This is private information. Or in other scenarios, they would not like to share the information because they want to challenge the student and so on. So this means there are all kinds of complexities around sharing gaze information or perhaps sharing heart rate information, sharing EEG information with others. But at the same time, these things can have a lot of benefits. So thinking about the tension between these two things, thinking about this situation where we want to utilize the technology in the best way possible, but we want to also do that in a human-centered way. There are all kinds of questions that we can start to ask. For example, what information should be shared? Would that be EEG information, eye tracking information, any kind of other information? And of course, when? When do we share that information and with whom? Do we share it with the whole team or just the manager? And of course, how much information would be too much? Sometimes in daily life, we call that oversharing. So a certain amount of information could be too much. And of course, as I mentioned, how can we best utilize these technologies and these types of information? So with this, I would like to conclude this short talk and open the stage for our panel members and hear their opinions and observations, hopes, and predictions, perhaps regarding the future of using psychophysiological information to help designers design better or to even teach design better in architectural design. Please feel free to jump in.
では、先に始めさせていただいてよろしいでしょうか。
はい。
どのような情報が有用かということに関して、心理生理学的なデータというのは非常に有用な情報を含んでいるというふうに思います。ただ、有用である一方で、決定的なことは言えない。つまり、 この反応が出たからこうですっていうのを1位に決めることができないという点が考慮すべき点になるかなというふうに思います。見えない、生体反応を可視化することっていうのは、とても大事な、インフォメーションになる一方で、その解釈っていうことに関しては、文脈依存的、つまりコンテクストディペンデントであるっていうことを、留意する必要があるかなというふうに思っています。でもテクノロジーが進んで、見えなかったものが見えるようになるっていうことは、非常に様々な可能性を含んでいると思っています。
Wow, that is a very interesting point about the fact that, first of all, we are making things which are invisible visible. Even with the gaze, of course, we can look at other people as they gaze at objects, but it's very hard to follow constantly and try to figure out what are they looking at. And of course, if we compare that with summarizing gaze information, we can never compete with that because we can aggregate, for example, information from 1 hour of gazing and then share that with someone else. And a person could never detect such information in a similar way. So yeah, this is a very interesting point. And the second thing is that the context really matters, and there is a difficulty in trying to interpret it in the right way or in an appropriate way. And that has a lot of ethical implications, actually.
Thank you. I also agree. I think it's really an exciting research horizon that you're outlining, and I think there could be so many applications. At the same time, stemming from my own work, we do a lot of work trying to understand how configuration affects face-to-face interactions. And one of the things that we're understanding is that eye contact, right, between people is critical. It signals engagement, um, and we're very much primed, I think, from an evolutionary perspective to make eye contact, to assess if a person is making eye contact. That has so many implications for our social interaction. In architecture, the situation is a bit different because people look at a model, often cases, or at a spatial representation. I think that also has the possibility of circumventing some of the ethical considerations, right? Because it's not about how, for instance, I look at someone's facial details or bodily details or something awkward in the environment. I look at a model. We are communicating through the model. So I think that from that perspective, the use case of applying shared gaze into the architectural studio um, is necessary because it's really easy to lose track, right, of what the other person is talking about or thinking about, and that could be a really good vehicle to converge people's attention to some extent. At the same time, a lot of the other work that we do is really looking into psychophysiological measurements, for instance, in care environments, but also in space stations. And one of the things that we notice is that people are very sensitive about their own information, increasingly, and aggregation is key. So if you really want to, or on the other side of it, trying to create a response to that information that is mediated by a third non-human party, right? So if the model slightly rotates to be able to orient the student or the design panel to a certain feature, because everyone's, you know, like you have with your camera, right? With your FaceTime camera, where the view moves in the direction of your the subject's face. So I think a similar thing could happen. It's easier when it's a third party, not necessarily sharing my precise and explicit gaze behavior with someone else, because people can, I think, feel uncomfortable. But this is extremely interesting.
Very interesting. The idea of some kind of mediation before transferring the information. Because when it's directly transferred, some people, or perhaps many people, will feel that there is something too personal or too immediate in that.
And maybe just to add to that, it's a double-edged sword, right? You're creating new stimulus that also distracts people's attention, right? Just the shared gaze visualization itself can distract someone from the actual object of conversation, which is the model or the design problem at hand.
True.
Yes. Yeah, so yeah, thank you first of all for the presentation, Yuval. That was very good. And I do agree with both Professor Nagamine and Professor Michal about the points of context is very critical, whether it is sharing for education's sake or sharing from a commercial stake, right? Because you can use very similar tools for, as what Apple and many of these companies are working on. One thing I would say from a geographer's perspective, sorry, there's some sounds in the back, is that there's a very popular topic in because I work a lot with human mobility data, like using mobile phone data to track where people are. And there's a lot of research on something called differential privacy. And in this field of differential privacy, it is about how do you like add noise or aggregate the data until the data is anonymized. So for example, we would add, I don't know, some Gaussian noise to the data, and then we would have some evaluation metric on whether that data is now, suitably anonymized. So this is something I never really heard of in physiological data. And it was something, yeah, I put a grant on a while back on how do we include noise in the data so that it would become indistinguishable in terms of an evaluation metric. I think that's one thing I wanted to mention. The second comment I wanted to briefly mention is I think this idea of mediation is very useful because watching raw gazes is a bit like looking at I don't know, a raw human mobility map is actually very difficult. And without an expert or some sort of advice on how to look, it also become not necessarily informative. It could be actually a distraction, as what Michal was alluding to. So but I do agree, like you do add biases in perspective when you have a mediator. But I do think it like not everyone would understand EEG or fMRI, voxel activation in your brain immediately. So how do we or what do we transfer is important. And then also yeah, and I think that also alludes to the privacy side because you're not sharing as explicit of information, and rather those information is now, a lot more private or suitably anonymized as we call it in the domain. Yeah, so these are my comments on that.
Wow, these are very interesting observations and ideas. I think that once we introduce a mediator, let's say there is a software module that takes the information and does something with it, then, like Professor Nagamine said, we enter the domain of interpretation, and that makes me think that if we do that, if someone develops such a technology, they need to consider the information or the visualization as a kind of proposed interpretation, because the real problem is that we really don't know, right? It's hard to access the mental processes, and we try to figure out, is that person stressed? Let's measure their pulse. Are they interested in this? Let's look at their gaze. But eventually, we never know for sure. Of course, there is a certain degree of certainty, but if multiple, perhaps, interpretations could be proposed to a piece of information that is taken from someone and not make a decisive judgment, that person is not interested in the slides. So in that case, yeah, it may be helpful. Um,
Yeah.
so
And
yeah,
yeah,
Stephen, please go ahead.
I do think like aggregating, I can imagine saying that most of the students are seeing this part of the area is of interest. That would be, yeah, a lot more privacy preserving than saying that that person explicitly. So I think having like also this kind of
Mm,
aggregation and is between individual across time in space, this different kind of aggregation can possibly reduce the pressure the students have on like sharing the data and how it, and then also it helps with the mediation as well, because you probably need multiple, I don't know, attention to really confirm. And yeah, with more samples, you also reduce the bias of like, the person is stressed because of like, non-matter. So in some case, having aggregate people feeling, stressed looking at this building would be a lot more like richer than just having, a single person. So yeah, I think there's many benefits in looking at this kind of aggregated kind of conclusions or summary of the data. Yeah.
And just
Yeah.
to add to what Professor Law was saying, I think at the end, we also need to consider that psychophysiological data is extremely noisy. And one way to circumvent it is not to try to clean the signal, but actually add more features such that you could arrive at an interpretation that makes sense. And I think that behavioral observations, what people are actually doing, there's a lot of research, as we all know, about gestures in architecture by our colleagues, and that's really foundational to architecture, but also to HCI. So I think that ideally, from at least from my side, not to play the devil's advocate for just a second, I would try to say, well, it could be interesting to think about a setup where you try to collect behavioral data, and then a setup where you collect psychophysiological data, and try to really see if you can non-invasively, without the psychophysiological data, still arrive at an understanding of the student state or the communication patterns that arise. So usually in kind of this transition from psychology to neuroscience, you start with a very, very strong hypothesis driven by behavioral data, and then you go ahead and test it at a cellular level at the lab, for instance, using mobile EEG and other sensors. So I think that this is no different. It's true that gaze sits kind of in between. I don't think it's all the way to the cellular level, and it's definitely not all the way to the observational end. So it plays a unique role. It's nor here nor there, and this is why it's interesting. But perhaps having a more of a real, trying to confirm or reject. What is the actual benefit of using gaze here to be able to understand the design dynamics?
Wow, there are so many interesting things here to talk about. I'm trying to think which branch to climb. Yeah. So I want to ask you, first of all, for Professor Gath-Morad, do you think that it's realistic to integrate, not compare, but integrate the information from, for example, gesture, and with other types of information to make an inference regarding someone's mental state, for example, gesture plus heart rate or something like that? I've never seen this kind of work, but I'm not sure. Maybe it exists.
Not that I know of. So I do know that there's actually, I'm wrong. There is one work by Martin Borzambel and Yisol, done at the Chair of Cognitive Science at ETH Zurich, where I did my PhD, that looked into eye tracking and gestures in the design process. So I think they looked at how gaze behavior and gestures interact to predict certain design strategies. It's published, and I think John Gioro was also a co-author. I'm not sure. Do double check, but I'll try to paste that in the follow-up. And I think that is being explored. The only issue is synchronization, right? Like we do with the problem that Stephen can probably elaborate on from the 100 Minds of Motion study, and we're facing similar issues in our experiment with the face-to-face interactions. Once you have all of these multiple data streams that are measuring at different intervals, especially in a real world frame movement type static, is very, very difficult to synchronize.
Hmm. Oh, it's really
Yeah.
worth to check and try to go down that path. Professor
Yeah.
Law, did you want to?
Yes. Yeah, no, from a data perspective, synchronization of signals is incredibly difficult, because
Mm,
different sensors come from different devices, and even a millisecond difference in the brain has a difference. So there are lots
mm,
of so people are building like devices that has multiple sensors to it, but they're incredibly expensive. That there's EEG, ECG, and all of it together. But there's also lags, right? There's also lag on how you feel and how you bodily react. So there's issues both in like the technical synchronization, which in some ways is a bit easier, but also in lags of like how we feel and also our bodily kind of reaction to it. So like matching the two is certainly not easy in many sense. I wanted to mention there was also someone I met recently in University of Tokyo, and they were looking at, and she was a dancer, and she was looking actually at bodily motions in Zen gardens, and also looking at the brain, kind of also doing, I think, also brain tracking and eye tracking. And because she was a dancer, she was also looking at gesture of how people or multiple people was moving around in the kind of architectural space. And yeah, I'll try to also put a link to an article. But yeah, there are definitely people looking more and more at like synchronizing multiple sensor data. And as Michal said earlier, UCL has a very large project called 100 Minds, where we try to see how people interact in this kind of almost lab-like environments. And then there was like both camera tracking, like many different kind of sensors that was used. That is the PI of the projects, Hugo Spears, Fiona Zitz, and they ran this an amazing project of trying to track how people interact in kind of lab spaces and using multiple sensors. And yeah, the synchronization of these sensors was incredibly difficult. Yeah, that's it. Yeah,
wow.
thank you.
So there are difficulties in synchronizing among the sensors and also difficulties in matching the response, the detection time with the timing when the actual response happened. Um, Maybe we detected someone feels stressed, but they are not stressed anymore. There is some kind of a delay, or yeah, this is really fascinating, which means that these things are quite difficult to realize. So I would like to ask Professor Nagamine. Um,
うん。
I think that when we measure eye tracking, usually we just measure a coordinate and rotation of the eyeball, or dilation of the pupil, something like that. Not so much. And then with EEG, the amount of measurements we take is tremendous. So I would assume that sharing such information would be extremely difficult. You also mentioned that there is a lot of noise in the data and so on. But from the perspective of measuring stress, for example, I know that you're doing experiments with people using all kinds of equipment to measure their stress level, for example, heart rate measurements and sweat and so on. How I would like to ask, how precise is the current technology which is affordable?
う
Because
ん。
if we're talking about, very expensive, high-grade devices, people will probably not be able to afford them, and then it would be hard to integrate them into realistic scenarios. But I guess that some tools like the Apple Watch that I showed earlier can tell us something, but would that something be informative or useful, or is it not enough and we need better technology to reach that stage of sharing the information about heart rate and stress and so on?
うん、なかなか難しい問題ですけれども、えーっと、そうですね。精度の問題を解決する上では、テクノロジーが、どれだけ、まあ、ミリセックであったりとか、非常に、 サンプリングレートが高く取れていくっていうことが、心拍を解釈する上でもとても大事になっています。で、今の技術っていうものが、例えばデータを保存するといった場合にも、データ数が増えれば増えるほど、その、メモリっていうものを増やさなければいけない。で、そのメモリは小さくなければ、モバイルには向かないわけですよね。ですので、技術革新とともに、私たちの心理状態、生理状態っていうのを、より正確に把握できるようになるということで、やっぱり技術の進歩っていうものもとても大事になってくるかなと思います。で、ちょっと先ほどの、動機に関する、点なんですけれども、とても、大事なポイントで、まあ、そこがはっきりと取れていないと、正確に、評価ができないっていうことがあるんですけれども、以前、カーロン先生と一緒に、イングリッシュラングイッジの、プロジェクトをやりました。で、あの時も、一つの空間の中で様々なセンサーを Bluetooth で飛ばしたんですよね。でも、それが、まあ、ノイズを引き起こし、計測全くできなかったんですよね。視線計測が。
そうですね。
なので、いろいろと取れる環境っていうものを作る。それ自体が、まあ、テクノロジーの発展というところが、一つの大事なポイントになるかなと思っています。まだまだ不十分だとは思います。
That's a great point. So even if we have one device or a few devices, we also need to be able to operate them in the environment in real time without having conflicts like we had in an eye tracking experiment where we had a lot of mobile eye trackers and there was a kind of interference between the devices and eventually we measured almost nothing. So this can happen even with simpler devices. And I also understand from what you said that the when we measure heart rate, the sampling rate is very important. So the same data could be interpreted differently if we measure it in a high resolution or lower resolution, which means that if we are not using the proper equipment, we may be misinterpreting the real situation, which would be a shame. So it's important to benchmark, I think, these technologies that we intend to use and see that we're actually measuring what we are thinking that we are measuring so that we can share useful information among the team.
I completely agree with the benchmarking, by the way. I think this is something that's not addressed enough and it's becoming critical, especially as psychophysiological measurements are kind of exploding in other fields where there is a lack of foundational knowledge and a lack of, the ability to interpret it is limited. So I think the benchmarking, even for PhD students, to understand what it means to have 10 lines of heart rate data, how do you actually compare that to a baseline RMSSD, things that really give you a sense of where you are without going into the wild or into an experimental setup unprepared.
Yeah. And I would also like to add to this, like from a more data science kind of perspective, there's also like a lack of data in general, like open data, or privacy preserved open data that we can, train our models or to. And I think it's quite important because like as you might know, or like how people respond is very different. Like you might have fMRI scan looking at stress and then slightly different areas are activated, different voxels are activated. So at the moment I was trying to do some work on some brain decoding and I realized that there's actually not much like really open brain data. And even if there is, you would also be skeptical on how they design an experiment. So for example, they were asking people to look at images for every 3 seconds and then conclude that this part of the brain was activated. But there's also the sense of like how in designing the experiment to capture this data and whether it is noise or whether it is signal. And I only think that once you get enough data and enough evidence, can we really, begin to show this, evidence that is required to create this mediator. In like I think in heart rate, I think with RMSDD like kind of HRV is a lot. There's a bit more, but like with some of the like I don't know how much open eye gazing shared eye gazing data is available. But if we want to make a mediator, a model that accounts for like a lot of heterogeneity among individuals across time and space, creating a data set and also related data science benchmark, I think is critical from a data science perspective, and also from like if the aim is to create a mediator. Yeah.
But
Yeah.
Yuval, just to bring the conversation back to shared gaze, I think shared gaze to some extent can get away with it because you're not necessarily dealing with stress or direct psychophysiological data. You're almost, this is why I said it's nor here nor there. And I think that because of that, there is an immediate almost validation of the fact that what you're collecting, right, the data that you're collecting reflects something that really happened, and we can interpret in a meaningful way. So for me, you're overcoming the interpretation difficulty by the mere, the nature of the data that you're collecting. The difficulty, however, is definitely ethical, privacy related, and also how that would actually inform design communication in a useful way and not in an possibly tedious way, right? Because sometimes you want to have your gaze drift, and sometimes you don't necessarily want to look at someone because you're thinking, right? So these are things that I would actually try to dig deeper into.
Yeah. Thank you for all of these great ideas. This is really fascinating to dig deeper into the different scenarios for future development of this technology. And I think that when we develop such technologies, we can do one of two things. One thing is we can do it in an evidence-based manner. So we have scientific knowledge, and we know that in this situation, this means that, and we develop the technology to share that information. Or we can do it in a kind of exploratory way, which is make the tool and then try to see whether it works. And I think both approaches have problems because if you just make something, you never know if that works, and you may have wasted a lot of time and perhaps money. And if you pursue the evidence-based way, you may never develop anything because sometimes it takes many years to prove that something is indeed the case. But it would be better, I think, for the future development of these technologies if the scientific knowledge from cognitive science can inform the development, and we can direct the course of developing the mechanisms for sharing so that they make an impact on the activity, while at the same time considering the ethical perspective and the user's perspective, which is extremely difficult. But as you have proposed earlier, there are all kinds of interesting ideas. For example, the aggregation of data in the form of group data. So group state, instead of the mental state of one person, there is the state of the group. So no one bears the responsibility for that information by themselves, and that probably will reduce the burden on individuals. So by itself, that may be a first step towards sharing such information without it being extremely intrusive. So we have just a little time before we conclude the panel. If would anyone like to add anything at this point? Nagamine Sensei or Professor Gath-Morad or Professor Law?
集団の、反応を見るというか計測するというのはとても大事だなと思っていて、で、コミュニケーションっていうものを、考えるときに、コミュニケーションの質っていうものを評価する。で、その技術として、サイエンス東京の三宅義弘先生っていう方が、その集団の中で人と人がどういうふうに 同調しているか、うなずき合っているか、そういうような行動、体の動きっていうもの、そういうものを計測して、うなずくとか、距離とか、そういうものから、作用関係を評価し、コミュニケーションの質を検討していらっしゃるんですね。そういう集団としての、共同作業っていうもの、そういうものが評価できるようになっているので、そういうところから私たちのコミュニケーションっていうのを理解していくのもいいかなと思っています。
Wow, that is extremely interesting. So there are already ways that we can evaluate the quality of communication, and perhaps these metrics or methods can inform the future development and also help to measure the degree to which these technologies facilitate better communication or not. Because as Professor Gath-Morad mentioned earlier, we're making new stimuli, or maybe it's Professor Law, or maybe both of you. But we mentioned that we are adding to this stimuli. So that means that we are changing the situation, and we want to know what is the impact after we have introduced that change.
But I still just want to say, I think it's a fascinating area of research. We shouldn't ignore a lot of the work that has been done in this area before, and often cases, qualitative methods combined with low-level behavioral observations provide very, very high quality insights. But perhaps shared gaze could somehow capture those in a way that's not as effortful because it's not done manually. That's a horizon that I'm really fascinated by.
Thank you. That's a beautiful ending comment. Professor Law, would you like to add anything?
Yeah. No, I also agree with Professor Gath-Morad comments earlier that gaze sharing sits really in between the very physiological kind of measurements and behavioral measurements, and there's a lot of value in analyzing this as a specific mode. A final comment like I would make is like, yeah, there is definitely always a trade-off between privacy and utility. I think has been demonstrated. The more noise you add, the more aggregation you add, and like the more you lose in terms of demographic, like individual data. You like 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 in some ways you lose utility when you're trying to trade off between the two. So there's always a question on like I think it's important to especially in an educational context that like the aim of the project is for the improvement of education. So therefore some sort of loss in privacy might be just better justified. And I think in many ways that is quite critical to set up in the beginning. And I think and yeah, I really enjoyed the talk, and I think this is a very useful way to bring this forward as well in the field. Yeah, thank you very much. Yeah.
Thank you, Professor Law. These are very insightful comments. We are right on time, so I would like to conclude this panel by thanking all of our speakers. I hope that our viewers had an interesting time listening to us talk about the sharing of psychophysiological information in design and in design education. And hopefully we can make progress towards developing these technologies in a human-centered way. So thanks to everyone.